Welcome to the genius world of monster engineering!
Each show, we're going to introduce you to 3 geniuses whose ideas have quite literally built the world.
We put all their epic brilliance to the test.
Hit it!
And we tackle our own genius monster build.
Don't you dare demolish this! Going higher.
Why is it swinging?
Faster! And scarier!
Oh, no.
All in the name of science.
That is a massive piece of construction.
What could possibly go wrong? On today's show, we're flying,
Frying!
perfectly cooked bacon, and fanning. Oh!
As we join the quest for everlasting energy.
Not too fast, not too fast, not too fast. I said not too fast. This is absolute genius. Welcome to Las Vegas!
We've come to the USA and to Las Vegas, one of the most power-hungry cities in the world.
Famous for its bright lights, it's a city in the desert kept cool by power-guzzling air conditioning.
For decades, it was powered by fossil fuels like oil and coal.
But it now hopes to be one of the first cities in the world to be entirely powered by renewable energy.
On this show, we're going to introduce you to 3 geniuses whose ideas are helping us get ever closer to everlasting energy.
Throughout history, humans have always used natural resources to generate power.
But in the late 18th century, we discovered electricity. And pretty quickly, we got hooked on the stuff.
Wowzers!
To keep the electricity flowing, we built power stations, burning supplies of coal, oil, and gas.
Oi!
But reserves of those are limited. So engineers have gone back to basics. And once again, we're looking to nature to give us energy.
Good old Mother Nature.
From sunny Vegas to windy Nottingham.
Which is just as well, because our first genius found a way to simplify how we get power from wind.
May we introduce to you Mr. Edmund Lee.
Do you mind?
This is a serious science program.
I think he needs an antacid chew.
But I'm the king of wind.
Using wind for power isn't a new idea.
More than 1,000 years ago, the ancient Persians used windmills to grind grain for eating.
But early windmills had a pretty big flaw. They needed a lot of manpower to keep moving the sails to face the wind.
All that changed in the 18th century when British inventor Edmund Lee came up with a genius plan to automate things.
But how did he do it?
And what's any of this got to do with Las Vegas?
Oh, we don't know, but there's a fella in there that does.
Genius helper John Billingham knows more than a bit about windmills because he's the miller at this incredible working mill near Nottingham. Mill. Hi, John.
Hey, John, how you doing?
Hi, Dom. How you doing?
All
Thanks
right.
for letting us into your windmill. How is this working?
Well, I mean, the clue is in the name. Windmill. The wind drives the sails, and the power is all brought down here to these big cogs here, which turns our grinding stone, and you might be able to hear the grain being knocked into the middle there.
So you're grinding grain to produce flour?
We are, yeah.
It's all working very smoothly inside the mill, and that's because Edmund Lee's genius idea is working its magic on the outside.
OK, guys, right, if you want to just look up there. Now, that bit that's on the opposite side to the sails, that is what Edmund Lee invented. That's what we call a fantail.
Right, like a mini windmill, but how does that work?
That fantail is attached to a gear system that goes into the cap. All the cogs, they turn together
Yes.
and force the cap frame round.
Cogs.
Cat frame cogs.
Lovely explanation, and thank you very much. But I didn't really...
Yeah, not meaning to be rude, John, but we didn't understand a word you said.
But there is one person that we know that can translate what you're saying into
yes.
our brains.
Fran!
Meet Fran, our scientist friend. Go! Who can explain things in a way that even we can understand.
It worked, Franny!
She loves a good experiment.
And best of all, she pops up whenever we need her.
Franny, everybody. Hey! Fran, stop! Stop! There are no leaves.
I know that, but this is not for blowing leaves, it's for doing science.
Well, you might be able to help us, Franny, because we don't understand what a fantail is. We need it simplifying.
Right, so what's the first thing that a windmill needs in order to work?
Wind.
Ta-da!
Aye, yep.
Any windmill?
So you might think that to make the sails of a windmill turn, you blow from the side, like this.
Well, it works.
It works, yeah.
It does, but you can make it blow much faster if you blow from head on.
Go on.
Like this.
Go on.
Okay, fair point.
So for the windmill to work the best it can, you want the sails of the windmill to always be facing the wind.
Yeah, but this is hard because we all know the wind changes direction.
Ah, it does.
To show us how the fantail ensures that windmills always face the wind, Fran's got a demo using a swivel chair and a bit of board.
This board is going to be like our fantail, and this is obviously our windmill.
Let's make some flour.
Okay.
Right, Fran, I'm coming over to join you.
Okay,
We're not
I'm
standing
ready.
over there with him.
Okay, let's do it.
Yeah.
All right.
So what happened?
Well, I'll tell you what happened. You blew this whiteboard, which turned Rich to the side, which meant that the wind was then blowing straight into the sails.
Exactly. And that was Edmund Lee's genius idea. He used the fantail so the windmill turns when it's side on to the wind, but when it's in line, it stops and points in the direction the wind is coming from.
There we have it, ladies and gentlemen. A Frantail fantail.
Because the fantail is at right angles to the main sails, it will catch the wind when they don't.
And via a system of cogs and gears, it turns them to once again face the wind.
Today's modern wind power turbines couldn't function without automation inspired by Lee's genius.
Still to come, we use the desert sun to cook up a tasty treat.
No gas, no electricity.
And we attempt to build our own unique, everlasting energy machine.
That's a serious amount of power you're pulling on there.
But before all of that,
We're back on the Las Vegas Strip, one of the most famous places in the world.
And this place owes a lot to a piece of monster engineering that you can find a few miles east.
This is the Hoover Dam. When it was built in the 1930s, people saw it as one of history's greatest engineering achievements.
standing at over 220 metres tall, there's enough concrete in the dam to lay a pavement that would stretch all the way around the world.
Our next genius is the woman who helped turn this place into a huge power source.
Introducing genius number 2, Edith Clark.
Oh, please call me Edie.
Edith Clark was America's first ever professional female electrical engineer.
Her electrical expertise and ideas were a crucial part of the Hoover Dam project. And her genius, hidden deep within this mammoth build, is still doing its job over 80 years later.
Edith didn't pick up a bolster chisel and get her sand and cement out. Oh, no, she didn't build it.
No, to find out what she did do, we need to go down there.
We're heading to meet genius helper, Kathy Stewart.
Hey, Kathy.
Hello.
How you
Kathy,
doing?
lovely to meet you.
It's nice to meet you too.
So this is the beast.
It's amazing.
Yes, that is Hoover Dam. It is one of the most amazing structures that we have here in the United States.
But what does the dam actually do?
It can hold back 9.3 trillion gallons of water.
Trillion?
Trillion.
By blocking the Colorado River, the dam creates Lake Mead. In doing so, it stores up the potential to power millions of American homes. But how?
Water falls through openings in these inlet towers. Powered by the immense water pressure of the lake above and the force of gravity, it flows down a system of pipes accelerating to high speeds.
When the water reaches turbines around 150 metres below, the flow sets them spinning, generating huge amounts of electricity.
Come on in, folks. What you're seeing is our generator floor.
Yeah.
And on this side of our power plant, we actually have 9 generators.
What was Edith's genius behind these generators?
She was crucial in the development of the technology used. She also was a pioneer in the use of using the environment to generate this electricity.
Oh, so that was a big passion of hers anyway.
Very much so.
Edith had helped create turbines that could harness the power of water on a scale the world had never seen before.
So we thought, how do you demonstrate the power of water in a very serious, experimental way?
Well, we've come a few miles down the road to do this.
These are water jetpacks.
They use the force of fast-flowing water not to power turbines, but to lift people up in the air.
Looks pretty easy, right? Rich, you'll be fine.
Good luck. I'm proud of you.
There he goes, TV's Mr. Action Man.
And if you've seen this show before, you'll know that I don't have a very good relationship with water. But in the name of science, I'll give it a go.
I can't wait to see him flying in the air. The world's most scared man.
I don't know how long this is going to last.
Go on, Reg.
Why do they keep making me do these things?
Oh, here he goes.
This all feels completely unnatural.
Oh, we got a bit more water pressure. That's it. It's up about that much.
In my head, I'm soaring above the lake.
Bit more thrust. Come on.
But you're not, are you? Your little chicken legs are just flapping
There you
about.
go, yes. His legs are out.
Enough, stop. This is just humiliation. Get me out.
There he is, the new James Bond, 00 Dickie.
What was that?
Well, I thought that went marvellously well. Went up a little bit, came back down again. Time for a brew, I think.
Right, shorts. See you in a minute.
My go. Different machine, same principle.
Come on then, let's see how it's done.
This is all your fault, you know.
I know, always is.
Hey? In fairness, this is nerve-wracking. But pretty quickly, I seem to get the knack.
Felt it.
I don't think so.
But after a few more goes, I seem to have nailed it.
Yes, 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 yes! Yes! Are you sure this counts as science?
There is no doubt that water is seriously powerful. And Edith Clark found a way to use it on a massive scale. Absolute genius.
Thanks to the tech behind turbines and generators, globally, hydroelectricity now produces enough power to supply over 1 billion people.
Still to come, we tackle one of our most ambitious and unpredictable monster builds yet.
But first, how about some renewable energy-based random genius systems? Genius systems!
In London town, sweaty heat energy from millions of underground travellers is being put to good use, heating hundreds of nearby homes.
Meanwhile, in Iceland, they also love a bit of subterranean power. Because there's so much volcanic activity there, the water that comes out of the ground is hot enough to heat homes and generate electricity. What?
And at wastewater treatment plants all over the UK, methane gas is being extracted from, wait for it, human poo. Yes, to create clean energy. Stinky, clean energy. So we can tick wind and water power off the list.
The best place to study our final genius is out here in the scorching Nevada desert.
We've got a thermometer and it's reading at 45 degrees Celsius.
Which means there's a lot of energy hitting this place from the sun.
Burning at 15 million degrees C, the sun is the most powerful energy source we have.
It's estimated that it transmits more energy to Earth in an hour than we consume in a year.
Now, our next genius worked out a way of taking all of this power and turning it into electricity.
Introducing to you, Edmund Becquerel.
It's so hot, I could cook an egg.
In 1839, a young French physicist called Edmund Becquerel was working in his dad's lab on an experiment with some chemicals and 2 metal electrodes.
When the sun shone through the window and hit the electrodes, Becquerel noticed that it had created an electrical current.
By accident, he'd made the first ever solar cell, and solar power as we know it today was born.
Literally brilliant.
But how, in the middle of the desert, are we going to find out about a French physicist?
I know, let's ask this guy. It's genius helper, John Howard.
Hey, John, how you doing?
Good, how are you?
Yeah.
Can you tell us a little bit more about what Becquerel did?
Becquerel was a scientist who discovered the photovoltaic effect.
Hang on, the what?
The photovoltaic effect. Combine the 2 words, photovoltaic, so light and voltage.
Oh, okay.
Solar power.
So what he did as a 19-year-old in his parents' basement was he had a solution of silver chloride, and he noticed that when he shined light on it, he established a voltage.
And this surely led on to solar paneling, is that right, or solar cells?
Correct. Today we use solid solar cells instead of the liquid ones for a number of reasons, and they're more efficient.
Solar cells can be found everywhere, from helping to power people's homes to fueling the International Space Station.
So this is a smaller version of what one might normally see on a house or on a building. Basically what we can show is that when we're shining this directly at the sun, we can actually get quite a high voltage.
So we're up at 4.6.
And when we take the light away, we see that the voltage levels will significantly decrease.
So if I was to cover it up...
Yeah, into the shade.
Yeah, yeah.
Oh, look at that.
The voltage level significantly drops.
And that's all down to Becquerel's genius.
Correct.
I understand why solar panels are here in the desert with the sun. You know, you get a lot of heat, but how do they work in the UK?
Well, fortunately, we don't need the heat as much as we need the light. As Becquerel showed with his experiments, it was the light that caused the voltage.
To show you just how powerful sunlight can be, we've set up a desert diner with a difference.
It's a solar cooker. Let's cook. Ooh, bacon sarnie. Look at that.
This dish is taking all of the heat from the sun and directing it all into one sweet spot, which is right underneath the pan at the moment, which I can see right now. It is so hot that it's actually cooking this bacon.
The condensed rays of the sun mean the pan is cooking at around 400 degrees C. That's hotter than a hob in your kitchen.
No gas, no electricity. Look at that! Perfectly cooked bacon. Right. Shame you're vegetarian. You're going to starve out in the desert. There you go.
How is it?
Delicious.
Is it good?
Same as cooking it at home.
The sun's almost limitless energy fuels life on Earth. But thanks to Becquerel, it can now also power our cities. Across the globe, solar panels and solar power plants are capturing that energy and turning it into electricity. And we're cooking bacon.
On our energy road trip, we've seen how Edmund Lee brought automation to wind power. And how Edith Clark helped harness power from water on an epic scale.
We've learnt a lot about the science behind how to produce everlasting energy.
And that's handy because our Monster Build Challenge is to design and make our very own unique power station.
Here's the plan.
Our power station will work along the principle of a Rube Goldberg machine. There it is. The name for an ingenious chain of linked contraptions that work by one thing triggering the next part, which triggers the next, and the next, and that triggers the next, and the next, and that triggers the next. And the deal.
Our machine will have to incorporate everything we've learned so far. Fantails, water power, solar cookers, and anything else we can think of.
The problem is, we've got the ideas, but we don't know how to make it. We don't know how to make it.
I have a plan.
What?
Grant.
Grant and his genius brother James have made some weird and wonderful builds for us in the past, and I'm sure this job's right up their street.
To show us how a machine like this could work,
Look, you've already built one.
the boys have rigged up a couple of standalone elements of a Rube Goldberg machine.
That's the name for a contraption where one thing triggers another in succession a few times, yeah?
Exactly.
Okay.
The first is a water-powered seesaw, loaded with a surprise.
As it fills up with water, the seesaw will drop straight down really rapidly. That goes up, pulls the string on the two party poppers,
Nice.
and bang.
Let's give it a go.
Right, water's going in.
Hey, look, you can see the resistance.
Oh, yeah, it's starting to move.
Wow, that was great!
Good work.
That was brilliant!
The next demo is all about fire.
You might need your safety goggles for this one.
Oh, good. Now, this is what I'm talking about. Fire.
Remember, Grant knows what he's doing. Never mess with fire.
We've got a fire pit here. This will ignite, hopefully burn through the string. That'll release our weighted wheel and smash down the blocks.
Yeah.
Okay.
Oh, yeah.
There you are, it's on it.
Right. Well done.
It might look simple enough, but Rube Goldberg machines incorporate lots of elements. And if even one of them fails, the whole thing is ruined.
It goes without saying that ours will be planned meticulously.
Start with a monkey.
A monkey? Leave it to the experts, mate.
A few balls going down a pipe.
We could switch on some form of solar power.
Nice, nice. Fry an egg.
The weight drops on a mousetrap. The mousetrap.
Then that needs to turn like a blade, a flat little fan or something, doesn't it?
Tick, 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 boom. So what have we got? We got
Wind.
seesaw,
steam.
monkeys.
Move on from the monkey.
Right, OK, monkeys aside, I think we've got a brilliant plan here.
Build it.
Yeah. Let's go.
As usual, it's now left to Grant and James to turn our nonsense into something actual.
3 weeks later, and they've only gone and built it.
Oh, grand. Looks like you've been hard at work.
I think you'll be impressed with what we've done.
The machine is a brilliant collection of elements, taking in everything from a drone to a racing car track.
Once it's rolling, it will power itself, but we'll have to create the initial injection of energy.
Tandem.
Using this bike with a difference.
Basically, we've hooked the back wheel up to an electric motor and created a dynamo. So you're pedalling, we're turning straight into DC voltage. Yeah, so you're at 28 volts. That's a serious amount of power you're pulling on there.
That voltage will send a toy car hurtling round a track fast enough to make a jump and strike this barrier.
If we get it right, it'll start the chain reaction and the barrier will pivot, causing a bright light to hit a solar cooker, like the one we used in the desert.
So hot that it's actually cooking this bacon.
This foam will be holding the ball up. You see that'll start burning. The ball gets released and down the tube.
The next stage is some Hoover Dam-inspired water power.
So we have water stored at a height.
Like the dam, the stored water will create water pressure by being funneled through a narrow opening.
Then turns the water wheel, so that's like a turbine, I suppose.
Exactly.
Right, and then it all goes into the bucket.
When it fills the bucket will drop down into position.
And all that should cause our giant finger to move.
But what does it control?
The drone.
Yes. Brilliant. But surely the drone's just going to fly off in the air.
Well, we've attached this piece of string to it.
And when it pulls the string...
Oh, yeah! Great!
And that leads onto the fantail. This should catch the wind, but instead of making a windmill change direction, it'll turn the blowtorch towards a huge pile of... that.
Yes, that.
And that'll create our explosive ending.
An explosive ending!
Nice.
What could possibly go wrong?
Everything.
If even one element fails, the machine won't work.
There's just time for one last test.
Go!
It works.
Yes!
Sorted. Right.
You idiot! It's broken. You idiot! Well, looks like we'll have to let Grant and the team fix that, I think.
Get your bag of spanners out. Come on.
A bit of mending later, it's time to give the machine a go.
Can we turn human power into a chain reaction of energy?
This is the only bit of the experiment that relies on us.
Let's find out.
You ready then, guys?
Ready.
3, 2, 1, go.
Not too fast, not too fast, not too fast. I said not too fast.
Let's try again.
Right. Slowly.
Slowly.
Could have just done one big straight, really, couldn't we, Andy? You ready?
Get off!
Again.
Slowly. Slowly. Slowly.
Ready.
Slowly.
Go! Yes!
That was too slow.
Too slow.
Too slow.
Okay, are we ready?
We're ready. We were ready the last time and the time before that.
I'm ready. I'm
now
doing
we're
it
ready.
properly.
Yeah.
It's him at the back.
Just go.
Right.
Get ready. Now take your feet off. Yes! Quick, quick.
Go, yeah, quick.
Yep, the burn's working.
It's gone. Yes, there goes the ball.
It's in the pot.
Smooth action.
There goes the turbine. Filling up the bucket.
Okay. When the bucket gets a certain weight, that's going to flip the switch.
The drone is airborne!
The drone's gone up, the fan's going. The poo's going to set on fire.
Once the dung is alight, the fire should release this truck, which should set the Absolute Genius logo on fire.
Poo power is lit.
The truck's going down.
Truck's going to go down.
Yes!
And it's lit.
It's going up.
Yes! What's going to happen?
Oh, Grant certainly delivered on his explosive promise.
Oh,
It
yes!
worked! Look, it all worked!
Result! Our Rube Goldberg machine worked a treat.
And in this episode, we've seen how the bright ideas of three geniuses have moved us ever closer to the dream of everlasting energy.
Lee, Clark, Becquerel, you are all absolute genius.